Sample problem 4.2 reads, what amount, or moles, of each ion is in each solution? A part says that we have 5 moles of ammonium sulfate dissolved in water. And one thing that I want to highlight here, notice the question is asking for moles of each ion, okay? Ammonium sulfate is made up of ions, right? This is an ionic compound here. Both of those being polyatomic ions. So our first step before we can answer this question is we have to figure out, how many ions do we actually have there? And so the formula for ammonium, if you'll remember from Chapter 2, is NH4 with a +1 charge. The formula for sulfate is an SO4 with a 2- charge. So what that means is for every 1 sulfate, I'm going to have a 2 ammoniums, because remember, those charges have to sum up to equal 0. So I'm going to have NH4, and I got to have 2 of those, SO4. So there's our formula. So now that we have our formula, we can begin to answer the actual question, right? So let's see. Let's start with ammonium since it's listed first in our formula. So I have 5 moles of ammonium sulfate, and the question wants to know how many of each ion, so I'm going to do ammonium first. So I have to figure out what conversion factor do I have available to myself that will get me from moles of ammonium sulfate to moles of just ammonium by itself. And so my conversion factor is actually the chemical formula, right? The chemical formula tells me for every 1 mole of ammonium sulfate, I have 2 moles of ammonium there. So if moles of ammonium sulfate's in the top, that's what has to go in the bottom. So from that formula, for every 1 mole of ammonium sulfate, I have 2 moles of ammonium. All right, let's check our units here. I've got moles of ammonium sulfate divided by moles of ammonium sulfate. They're going to cancel out and equal 1. And now I can say 5 times 2, which would be 10 moles of ammonium, NH4 with a plus charge. Okay. And now I'm going to do the same thing for the sulfate, right? So that's the first part of the question. I've answered how many moles of that first ion, right, the ammonium. So let's see if I've got 5 moles of ammonium sulfate, right? Again, I've got to get from moles of ammonium sulfate to moles of sulfate. That formula tells me that for every 1 mole of ammonium sulfate, I have 1 mole of sulfate. So let's go ahead and write that in our T. That has to go in the bottom, ammonium sulfate, right, because it's in the top. NH4, 2SO4. For every 1 mole of SO4, 2 minus. Moles of ammonium sulfate divided by moles of ammonium sulfate cancel out. That's going to equal 5 moles of sulfate, SO4. Let me get a little more room here. 2 minus charge. All right, and now B part says that we have 78.5 grams of cesium bromide. So just like in A part, we first have to write our formula for cesium bromide. And if you look at the periodic table, number 55, cesium is going to have a +1 charge. So let me write that down first. Bromide, the bromide ion, it's got a minus charge, Br with a -1. So that means I just need 1 of each of those, right? So cesium bromide. And it tells me that I have 78.5 grams of that. And the question's asking for the number of moles of cesium and then also the number of moles of bromide, right? It wants to know moles of each ion. So I got to ask myself again, what conversion factor do I have available to me that will convert from grams of cesium bromide to moles of cesium and from grams of cesium bromide to moles of bromide? And the key thing being here, right, I'm trying to get from grams to moles. And the conversion factor that does that is the molar mass, right? So I'm going to have to get the molar mass of cesium bromide from the periodic table. So let's see here. That's going to be 1 cesium plus 1 bromide, and I got 212.8 grams of cesium bromide in 1 mole of cesium bromide. Remember, the periodic table tells us those units, right? The grams per 1 mole. So I've got grams divided by grams are going to cancel, and I'm going to be left in moles. So let me see here. What am I going to get? 78.5 divided by 212.8 equals, and I got 0.369 roughly. Moles of cesium bromide. Okay. And if you'll notice, right, from the chemical formula, for every 1 mole of cesium bromide, I have 1 cesium, and for every 1 mole of cesium bromide, I have 1 bromine. So that means that I would also have 0.369 moles of cesium, and also I accidentally put 2 pluses there, I only needed 1. 0.369 moles of bromine, right? Because it's a 1-to-1 molar ratio looking at the chemical formula. So I didn't even set up my T there that time. I just kind of went straight from it, just knowing that it was a 1-to-1 molar ratio. All right, C part says that we have 7.42 times 10 to the 22 formula units of copper 2 nitrate. So again, we have to figure out what is our formula for copper 2 nitrate. And so copper 2, that means that it's got a 2 plus charge, right? That Roman numeral there. Nitrate is an NO3 polyatomic ion with a -1 charge. So that means that the formula for those guys is then going to be copper, and I got to have just 1 of those, and I need 2 of those nitrates, right, because it only has a -1 charge. So now, what conversion factor am I going to use? I have formula units, or the number of copper nitrates, and I'm trying to get to moles of each ion. So what conversion factor do I have that will get me from, the number of things to moles? And the only one that we have, right, is Avogadro's number. Remember, Avogadro's number, I'm going to write it up top here. 6.022 times 10 to the 23 tells me the entities, and entities can be anything, remember, per 1 mole. Okay, so let me set up my T right here, and I'm going to use Avogadro's number, which tells me that I have 6.022 times 10 to the 23 entities. This time, my entity happens to be the copper nitrates in 1 mole of copper nitrate. Let me extend my T there. All right, let's do our math right there. For our units, they're going to cancel out, and I'm going to be left in moles. So let's see, I've got 7.42 times 10 raised to the 22 divided by Avogadro's number, 6.022 times 10 raised to the 23 equals, all right, and I need some more room to write again, so let me shrink some. Well, that's doing weird stuff. Let's move that there. That goes there. That will go kind of there. We go. No, I'm all messed up. Oh well. I just need some more room, so I'm just going to shrink this and move it up there, and that goes there. Sorry, guys. This thing's being weird on me. All right, and then I'll move this up out of the way. All right. Now let me write my answer down. I got 0.123 moles of copper nitrate, NO3, well, my 2 of them. And now the question's asking for the number of each individual ion, right? So if I've got 0.123 moles of copper nitrate, I'm going to do copper first, right? How am I going to get it from moles of copper nitrate to moles of copper? I'm going to use the molecular formula, right? It tells me that I have 1 copper for every 1 copper nitrate. So copper nitrate is going to go in the bottom. For every one, I need to put moles there. For every 1 mole of copper nitrate, 3, 2, I've got 1 mole of copper. All right, so that just means I've got 0.123 moles of copper. All right, and then if I've got 0.123 moles of copper nitrate, for every 1 mole of copper nitrate, I've got 2 moles of NO3 minus, right, of my nitrate ion. So that times 2 is just going to be 0.246 moles of nitrate. All right.